All right, hello once again, Jeff Scott, formerly of Rankin Technical College. And what I have been doing is I have been going over, as part of my YouTube channel, JPS-Jeff Teaches Programming, and the YouTube playlist, Jeff Teaches Programming Python. I've been going through an example of a Python set for this payroll program, and I got stuck. All right, with a discard. Okay? And it's funny because I was talking to an associate about this who said to me, hey, why don't you just put it into ChatGPT or one of the AI things and let it figure it out for you? I don't want to do that because this is supposed to be a learning channel. All right, that's what I'm trying to do here. You know, so far I've gone through, in this example, again, we're not doing the add, we're not doing the clear, although if we did, I showed you how. We did the copy, we did the difference, and we did the difference update. And now for this discard example, I'm going to remove what's here. And I went out and started to read, you know, different things on how I could possibly do this. And this is one of the better ones that I came up with. The Python iter and next, as it says, to convert an object into an iterator. So we're going to look at that. So that'll be the link for it. And I'm going to put in the code because it's only a few lines long. Again, we want a global here. And, you know, where do we want to discard from? Well, let's take the well-paid workers. All right. We don't even, you know, we're just going to discard from one. So I don't need to have employees. I don't need to have overtime workers, although I could use one of those as well. Let's put an F string in here, and then let's put in, I don't know, the original well-paid workers set, to which we will add, you know, well-paid workers. All right. All right. So let's take a look and make sure that works before we do anything else. All right. So let's go back to our beginning here. And let's run this. Again, all I'm trying to do is I'm trying to go through and make sure that it gives us this list of 16 people when I go in and do the discard, which is number 5. So, am I getting that? I'm going to take for granted, it starts with Sophia Anderson and it ends with Layla Bronson. Sophia Anderson. Well, I don't even see Layla Bronson in here. All right. But I'm going to take for granted that actually this is okay. Now, maybe it's not. Okay? But I have to check through each one of these on their payroll to make sure that they're all making the right amount of money. But what I want to do is I want to come through here, and now I'm going to run the program again in a second. But let me add my code first. All right, so you saw this. All I did was print out the original list. That's it. And then let's have an employee to discard. All right, and we're going to say the next iter of well-paid employees, or well-paid workers. All right, and then when we get done, we're going to do another print, but we're going to print, instead of the original, we're going to print the updated. So we're going to print this, so the well-paid workers set after employee to discard. All right. All right, so I'm going to grab one, and now I'm going to say in here, well-paid workers dot discard, and that'll be that employee to discard. All right, now we're going to print it out again. All right, so let's see if there's any difference between these two. So again, we'll do a save all. I'll come back to here and I'll run this. We're again going to use number 5 for our choice here. All right, so let's see. All right. So when you look over here, okay, Abigail Martinez, Ava Williams, etc. Abigail Martinez, Ava Williams, etc. You might look and say, well, I don't know if anybody has been discarded. Let's see if we can check and see if indeed someone was or was not discarded. All right. So let's see. Let me come in here. And let me do this. Okay, so this is the original. Okay. Let's put these, try to put each one on their own line. How's that? Okay, looks like there's about 20 of them. All right. So now let's take a look at after we did the discard. And let's see if we still have the same number and if they are the same. Or if indeed we were able to discard some. An employee. So when we take a look here, looks like I might have goofed this one up, but we'll fix it. Oops. All right. So now we look at it. This is after the discard. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. Let's look at the original list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It actually looks like we got rid of 2 of them. Well, we've run this twice, which could be the reason why. All right, not positive, but let's take a look here. So we've got, there's Abigail Martinez, but when you look here, we had Amelia Miller. And when you look here, we have no more Amelia Miller. So we were able to have it go in and grab the next one and remove it. Let's try to run it again and see if we run it this time. If we remove, so we removed Amelia Walker. Let's see now if we remove Abigail Martinez. All right, so I'm going to run it again. All right, and when you look up here, okay, I do not see any more Abigail Martinez. All right, now, when you go through this, if you go through this, and we take a look here, it says, in many cases, we may need to access an object in a way that treats it as though it were an iterator. All right, as it says, we want to interact with the object, and we want to be able to loop through it. All right, so we are using here in this example, the ITER, all right, as it says, it returns an iterator for a given object, such as a set. It creates an object that can be accessed one element at a time using next. So we're using a combination of next and iter. All right. I thought there was an example in here. And I grabbed a couple of these, so maybe, let's see. Can you explain the purpose of ITER in Python? As it says, it's used to make an object such as a set iterable, meaning you can basically loop your way through it. When you define iter in a class, it should return an iterator object. As it says, it allows you to use the object in loops. And that's what we did. What does the next method do? Get rid of this. The next method, as it says, is used to get the next item for an iterator. So that's what we did. And we told it to run the discard method on that. So in other words, we told it to get rid of that particular element. All right. So let me quit because I think we've got that one done. So we now have done 0, 1, 2, 3, 4, and 5. All right, and 17. All right, so let's go on. Let's continue on here. Okay. And the next one after discard was intersection. And I'm actually going to write this twice because there's an intersection and then there's an intersection update. Well, I don't know what the hell happened there. Yes, I do. All right, so there's the intersection example right there. Okay, let me just grab that. That's all I wanted. So we've got intersection and intersection update. They're not going to be the same. If they were, why would we have two different functions? But let's start with the intersection function here. All right, I'm going to have a global. What we want to do with the intersection is we want to see what's in common between two sets. So we will use the overtime workers and our well-paid workers. All right. And we'll say intersection workers, we can call that whatever we want, equals well-paid workers dot intersection of overtime workers. All right. And then we'll just print that. So let me grab this print line that we've steal the one that we've got from here. Probably would have been faster just to type it in. So the intersection workers So again, these should be the ones when we do an intersection that exist in both. All right. So let's see if that one works. That'll be number 6. In fact, right here, okay, I'm getting that error. And for now, there's other ways I can handle this, but I'm just going to comment this out because we're going to do this one in just a moment. All right. So file, save all. Let's go back to here. Let's run this and try number 6. Remember, here's our 2 lists. So, when you take a quick look, who should be in these 2 lists? Well, one of them has already disappeared, it looks like. But there's the well-paid ones. So let's run number 6. All right. And you'll notice we get Victoria Thompson. Let's look at these. Okay, Victoria worked more than 40 hours, makes more than $20 an hour. Luna Wilson worked more than 40 hours, makes more than $20 an hour. Evelyn Rodriguez worked more than 40 hours, makes more than $20 an hour. Penelope Martin worked more than 40 hours, makes more than $20 an hour. Abigail Martinez worked more than 40 hours, makes more than $20 an hour. Sophia Jones worked more than 40 hours, makes more than $20 an hour. And Aria Moore worked more than 40 hours, makes more than $20 an hour. It appears as though that one works. So we now have 0, 1, 2, 3, 4, 5, and 6 finished. So let's continue on. The next one that's here is our intersection update. So let's uncomment that. Let's write this one. All right. Again, we'll say global, just like we did before with the well-paid workers and with the overtime workers. The order in which you put those, of course, wouldn't matter. All right. Now what we're going to say here is just kind of what we did before, but we're running an intersection update. So in other words, I'm going to grab this where we did the intersection, but instead of doing an intersection, we're going to do an intersection update. All right. And then we'll print so this will be like that. All right, let's go back and take a look here. And I'm sure I don't even have this up there anymore, but let's bring it back up. So w3schools.com. We'll go to Python here. I'm going to go to sets. You've seen me do this before. I'm going to go to set methods. All right, so I'm down here to intersection update. Removes the item in the set that are not present in the other set. All right. All right. So when we get done, well-paid workers should look just like intersection workers that we did before, because we're telling it to remove any of the ones from overtime workers that did not match well-paid workers. So let's save. Let's go back to here. Let's run this. And again, this is like number 7 or whatever it was. 7, yes, it is. So now what you'll notice, oh, it's giving me an error. Intersection update example. Okay, so let's see, did I not call it example? Probably. Oh, that should be a capital E. My error, sorry about that. So let's run it again. So run the right file. So again, all the ones that you saw in the overtime workers that didn't match well-paid should now be removed. Okay, still doesn't like something. Oh, when I called it, I think I left that out. Boy, oh boy, Jeffrey. We'll get it working just a second. So that's, oh, look at that. Of a date example. Hopefully that was the error. Let's see. I'll keep sloshing on through here. All right, so 7. Now, when you look here, this Evelyn Rodriguez, in fact, what I'm going to do is I'm going to do this. So I want you to see this and the fact that I believe at least it is working. So we're going to get rid of this, replace it with that. All right, so these are our well-paid workers after we did the update. There are 1, 2, 3, 4, 5, 6, 7 in here. All right. So when we run this program again, let's quickly run it. So let me stop the run. And let me start the run again. All right. Now, there's our overtime workers, right? Whoops, well, okay, here's our well-paid workers, all righty? So, who are we going to remove from here? This is what I want you to see. All right, Layla Bronson is gone. Notice did not work overtime. Sophia Anderson. Is gone. We got Sophia Jones in there, but Sophia Anderson did not work any overtime. Harper Davis is gone. Did not work any overtime. Penelope Martin is still here because she worked overtime. Sophia Jones is here because she worked overtime. Mia Garcia is not here. No overtime. Aria Moore is here. Worked overtime. Ella Hernandez, not here because no overtime. Victoria Thompson is here, worked overtime. Camelia Gonzalez, not here because worked no overtime. Avery Williams, Ava Williams, Chloe Perez, none of them are here. Why? None of these 3 worked any overtime. Scarlett Jackson, not here, did not work any overtime. Evelyn Rodriguez is here because Evelyn worked some overtime. So that one is now working. All right. So as of right now then, we have gone through and done, I don't know, the first about 7 or so. Let's continue on. So after intersection, the next one that we had, after intersection update, I should say, after that, the next one we had was is disjoint. In fact, we got an is disjoint, an is subset, and an is superset. So this will be the is disjoint example. All right, again, we'll say global. And we will have our well-paid workers and our overtime workers. And I'm going to do a print here, and we'll do a print, and we'll just basically ask the question, are well-paid workers and overtime workers disjoint? All right, and what we'll put in here, we'll do it right inside of here. So we'll say well-paid workers dot is disjoint. overtime workers. Okay, so we've got everything right inside of there. Now, I'm going to try to make my life a little easier here, and I'm going to copy this down. So we've got is disjoint. So let's do this next one, which will be is subset. All right. So here we can say is well-paid workers a subset of overtime workers? And we'll run the is subset in here. All right, and then we'll copy this one and just change the subset to superset. All right. So is this a superset? This should say is subset, is disjoint, is subset, is superset. All right. Now, let's quickly look at these. Subset means, in this case, we're saying, is this a subset of this? So do all of these records exist in here, plus possibly more records? All right. Is this a superset of this? Same kind of thing. All right. But if you look here under what we had brought up, so the is disjoint returns whether there is any intersection. The is subset, whether another set contains the set or not, and whether all the items are present in both sets. You can also do it with either one of these. And the superset returns whether the set contains another set or not. All right, so let's try these. These are going to give us, if I did it right, some true or false answers. All right, so we'll move up to here. We'll bring this up. All righty, we'll run this. I'm going to go in and take out where I have been clearing this stuff, because that's why we're missing seeing both of these. So those clears, I'm going to probably take those out. So is disjoint would be an 8. Are they disjoint? It's saying here, no, they're not. All right, let's try a 9. Is well paid a subset? No, it's not. Let's try 10. All right, is it a superset? No, it's not. So it's returning a value of true or false. And let's put a \n in here, and in here, and in here, just because it'll read a little nicer. All right, and I think I already added all the rest of them. Yeah, I did. Okay. All right, so what's left? Well, looking at our list here, we're now up to here. We've got pop, remove, symmetric difference update, union, and update. All right, so let's start with pop. And what pop should do, as it says, is to remove an element from the set. All right, so we only need one of these. This time, let's work with the overtime workers. All right. So I'm going to come in here. This will be a def with a pop example. And we will use global. And we use the overtime workers. And we'll print in the original overtime workers set. All right. And that'll be overtime workers. Okay. Then we'll say removed employee equals, and we'll say overtime workers dot pop. All right. Then we're going to print off the removed employee. So we'll say here removed overtime worker. Okay, and that'll be the removed employee. And then we'll print in the overtime set after removal. And we'll say here, this will say before removal. All right, so let's try that. Now, if this works, you can see that we're getting down here now. All right, I don't know why that's printing out multiple times, but it is. So we'll have left remove, symmetric difference update, union, and update. So we are getting there. We'll have 5 left if this one works. All right, so let's run this. Take our last run and stop it. There it is. And run this. All right, so that would be 11. All right, giving us an error. No problem, we're going to fix it. All right, it says remove example. Telling us there isn't one, so let's double check. So that would be in our menu. That should be here under number 11. Oh, there it is, PSM remove example. It's there, but let's go look here. 11, pop, set method. It says it has no remove example. Well, what did I call this? Pop example. Well, I'm off one, so let me try that again. This is pop example. So this is pop example here. I don't have a pop example. There you go. I've just got to remove. So we're going to put it in right now. This will become an 18, so I'm going to move all of these down one in just a second. But first, let me grab this. So this is going to become pop example. All right, this will become a 12. $13, as I skipped one. $14, $15, $16, $17, and $18. This will have to change. All of these will change, so we'll have to put in there a new. See, that was number, for pop example, that was number 11. So we'll grab the current number 11, which we have in there. So am I missing something? Let's quickly look. Add clear copy difference update. Add clear copy difference update. So 1 through 5 are good, or 1 through 4. 0 through 4 are good, starting with 5. Discard intersection update, then is disjoint, is subset, and is superset. All right, discard intersection update, is disjoint, is subset, is superset. All right, so we're up to 11 here. Okay. All right. Pop, remove, discard. Pop, remove, this should be symmetric difference here. I don't know how I got another discard in here, but somehow it's screwed up, but that's okay. So we'll get rid of this 13 that's here. Let's see what's the best way to do this. I guess would be to move all these up. Try that again. So 12, 13, that would again become 14, then 15, then 16, as we had it before, and then 17. So I'm just trying to make sure I've got these two things synced up with one another. So remove symmetric difference, symmetric difference update. Remove symmetric difference update. So then I should have union, update, and exit left. Union, update, exit. All right, everything is cool. All right, so I am up to my pop example now, which now is in here. All right, so let's save that. And that'll be number 11 if I do it correctly. All right, so here I'll need my number 11. All right. And it's got everybody in here. Victoria Thompson, Penelope Martin, Sophia Jones, etc., etc. And I'm going to try to check these to make sure that indeed something happened. And you can see I keep going back, and I'm doing this as a testing mechanism. So this is the original. What happened here? All right, there's 9 in here if I counted right. One, 2, 3, 4, 5, 6, 7, 8, 9. And then let's look in here. Oh, what the heck? Look at this. Last one should have been Madison White. And it is. Okay, somehow this is, I goofed this up. Oh, this is the one I'm removing, is Victoria Thompson. All right, she should be the one who has been removed. All right, so after the removal, you'll notice that after the removal, we only have 8. 1, 2, 3, 4, 5, 6, 7, 8. We removed Victoria Thompson, who was at the top of our list. So that one's working. So we've got pop done. Let's go into remove. I'm at 40 minutes, so I'm doing okay. And with this one, I went back, and again, I'm going to be using, it's not going to be that different from some of the stuff we did in here when we used that iterator. So let me grab this. This is going to be our remove, because remove is similar, not the same, but it is similar to discard. So this is going to be remove example. I'm going to get rid of that. Let's look at our write-up here. So removes the specified element. Now, if you look here, if we go to discard, remove the specified element. Well, let's click on remove. And it says it's different from discard because remove will raise an exception if the error does not exist and discard does not. So if we had tried to remove an employee that wasn't there with, if we tried to remove an employee that wasn't there with discard, nothing would happen. If we tried to remove one here with remove, we'd get an error. All right, so this is going to be employee to remove. All right, let's change that. And let's change that, whoops, like that. So after employee to remove. Okay, other than that, it pretty much works the same way, but we're removing an existing employee. All right, now I put this before my pop, and I should have it after my pop. Like that. So let's try the remove, and let's see if that works. I believe that was like a 12 or something like that. Yep, 12. So again, I've got Evelyn Rodriguez here. Oops, try this. My first one was Area Moore, and you can see she's gone. Okay, so that one's working. All right, now we're up to symmetric difference and symmetric difference update. So as I've kind of been doing here, I'm going to write this twice. So this first one will be a def symmetric difference example. All right. And this will be symmetric difference update example. Let's fix these or fill these in right now. Now, what is the symmetric difference? Okay. See, we're down to the last 1, 2, 3, 4 here. This returns a set with the symmetric differences of two sets. Okay. So here we've got Apple, banana, cherry, Google, Microsoft, Apple. And what are we getting here? The ones that exist in either set, but not in both sets. Kind of the opposite of an intersection. Let's call this symmetric difference workers. We can call it whatever we want, of course. And that's going to be equal to and as always, when we're done, we want to print something. Like that. Get rid of that so you can see what I did. All right. So symmetric difference workers equals well paid dot symmetric difference. And the other one, I think the next one is going to be the same, but we're going to run the symmetric difference update. Okay, so let me grab this. So this will be symmetric difference update. There. All right, so let's see if these two work. Let's put a \n before each of these. And I'm trying to be consistent in my runs here. And I wasn't here. Looks like I've done it everywhere else. So File, Save All. Let's go back to here where we run our program from, and let's run it. So again, this is the symmetric difference and the symmetric difference update. Okay? All right. So that'll be 13. So these should be I'm looking in here. I believe this is everybody who is in well-paid workers. All right. You know, so notice more than 20, 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 more than 20. Well, there's one that would seem to say that that isn't correct. Same with that one. Let's take another look at it. All right, remember what this is. These are ones that are in one set, but not in the other set. Okay? All right. So I believe indeed that that is working. So let's try it again. Just to be sure, I'm going to stop the run and run it again and then put in a 14. Now, all these sleep then clear that I have in here, I'm going to comment those out. And, you know, it's up to you to put them back in if you want to and take a look at what's in there. All right, symmetric difference update example. I don't think I think there's a difference in the way I call these things, so we'll fix it. Symmetric difference update example. So this should have been like this. And when you look in here, symmetric difference update example. Symmetric difference. Oh, there, I think I've got, nope, update example. Update example. Boy, oh boy. So let me run that again. And again, this should be 14 out of the 17 that I'm doing. So let's put a 14 in here for the symmetric difference update. Oops, try it here. Says there are none. All right, let's see what that means. Oops, son of a gun. So again, in sets here and in set methods, we have gone through and done. We're not implementing add or clear. I showed you how to do the clear. I'm not doing the add. We've done this in other examples. I did the copy, difference, difference update, discard, intersection, intersection update, is disjoint, is subset, is superset, pop remove, symmetric difference, and now we're doing the symmetric difference update. So it removes the items that are present in both sets and inserts the items that are not present in both sets. When you look at this, I did do it correctly. Symmetric difference update. So let's double check. I'm going to take for granted that this worked. Maybe that's a silly thing to do, but that's what I'm going to do anyway. All right. That's the old run. So this is the run right here. And it said symmetric difference workers none. But if we look here at our method, well paid, symmetric difference update overtime. Okay. What if we tried to reverse this? What if we said here overtime workers and we did this with well paid workers? No idea if this is going to give me anything different or not give me anything different, but we're going to try it anyway. So file, save all. So run this and try it. So again, this is number 14. Still says there's none. The syntax is right. I'm not sure if there is a problem in there. I'll try to look at it to double check, but I want to go on and just do the update and the union. Okay. Why? Because I want to move on and start getting into object-oriented. So this will be the union example. And this will be the update example. Okay, we're going to write both those right now. So the union example, let's union these two sets. And I don't want to do it like that. Let's just say union of well-paid and overtime workers. I like it better like that. And that's going to be equal to well-paid workers dot union overtime workers. Oops. All right, and then let's print that. All right, let's see if that works. Like I said, we're getting down to the very end here. All right, so let's run this. This will be 15 of 17. Now, what I probably should have done first, there's the union. All right. And you'll notice when you look in here, well-paid workers, I've got some that are not. And, overtime workers, some that are not. And in the well-paid workers, there should be some that are in here that are making less than $20 an hour. I'm looking for one. There's one. Right, so it looks like I was able to union those correctly. All right. Let's do the last one here and then put this particular example to rest. It took a lot longer than I thought it would. Again, I'm up near an hour here. So let's do this last one. Let's just grab this and we'll make some changes. All right, so global both. Here we're just going to say well-paid workers, not dot union, but we're going to say dot update. Oops. All right, so file, save all, back to here, into here, we'll run it. This will be number 16 of 17. There it is. Again, I'm going to take for granted, maybe wrongfully so, but I'm going to, that it worked. All right, so this is what I'm going to do just so you can watch. I'm going to do a file, save and close everything, close each one individually. All right. Okay. Now I can close that. Now they're all closed. Now, when I was doing this, I threw it into a folder that was called test. So there is everything. It's got today's date on it. It's got everything in there. What I'm going to do is I'm going to go back up to where I had this. Let me copy this. And then let me go up to where I've got everything, my source files. So this is Python Payroll. Python BMI and Payroll, lovely. Let's see. Payroll non-OOP. So these are old. Get rid of all those. I'm going to replace them with the ones I just made. All right, I don't like doing it like that, but that's fine. There we go. Should work. All right, so that's everything. So let me do this. This is Python, BMI, and Payroll. There is a Git in there. And hold on for just 1 second, please. Making sure my battery doesn't go. All right, so let's go out here. Let's go out here, and let's go out to GitHub. Oh my goodness, come on. All right, 659 255 should be working now. All right, let's come in here and type in Python again. Python, BMI, and Payroll. Right now, you'll notice it's empty. All right, so I'm going to come in here and do this, and then I'm going to push it. So let's do this. We're going to do everything we're supposed to do here. In other words, I'm going to start with a git add dot git commit -m Python, BMI, and non-OOP payroll examples. Okay. Make sure that that's set correctly. Oh, I thought I had it, but I would need my git remote here. Says remote origin already exists, so let's see if it's correct. So git remote -v, and that is correct. All right, so we can push it. So git push -u origin master. Hopefully it'll go without a hitch. Looks like it did. So I should be able to refresh here. And there they are. All right, so you've got all those now as well. All right, I'll be back in just a bit, and I'm going to start on object-oriented programming. I'll see you then.